Today's lesson, 4.8, perform congruence transformations. All right, a transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. The new figure is called the image. So it's the image of the original. So anytime we perform a transformation, the second thing that comes out after we after we move a triangle is going to be the image of the original triangle. All right? All right, so I figured we'd have a little fun with this today. And let's move on. So there's three main types of transformations. Translation moves every point in the figure the same distance in the same direction. You look at my man Scoop here. Scoop is Scoop. It don't matter whether he's on the left side or the right side. He's still Scoop. If I move Scoop across the room, he's still going to be Scoop. Right? So nothing changes except where he's located. So he's going to be the same size, the same shape, and everything. So every point on Scoop moves the same distance in the same direction. This point moves this far. This point on the hair moves this far. Nothing changes. His nose moved that far. It's all going to be the same distance. I mean, I'm not perfect, but if we take him, move it up like that so that it's level. Now if we take this line and we move it, his nose is going to be the same distance apart, and his shoulder is going to be the same distance apart. See how everything moves by the same amount. We have nasty teeth. Yep. So it all moves the same distance. Thanks, Scoop. A reflection uses a line of reflection to create a mirror image of the original figure. So here would be our line of reflection. When I click on Tay, see that? He just flips over. Nothing special happening. He's not getting smaller. He's not getting bigger. Still Tay. He's just flipping over a line. Right? So he's reflecting over the line. Now there are horizontal reflections and vertical reflections. This is a horizontal reflection because he's reflecting horizontally. Hey, stop doing that. You're going to get dizzy. All right, on to the next one. A rotation is whenever a figure turns about a fixed point called a center of rotation. Now, the center of rotation is the one point that you could like stick your pencil on and spin the rest of the thing around it. I know you've all done that, like in elementary school, where you put your pencil down on a piece of paper and you spun the paper with where the pencil, like the tip of the pencil was. That is a center of rotation, where your pencil point is. Another center of rotation is with the fidget spinners that were all the big deal last year, year before. That middle piece that you hold is the center of rotation. Everything else rotates around that. So if you're looking at Zay here, his center of rotation would be like right in here. I'll do it in red. Because everything else will rotate around that one point. See how that works? It's all spinning around that point. Now in geometry, our center of rotation is going to be a little different. It's not going to be inside the figure, but there's no way to do that on this presentation on the smartboard stuff. It would be like outside of here. We would have a line going to Zay's leg. He would actually be spinning around this point. So it would be the whole thing spinning like downwards. We'll get to that though. These types of transformations are called congruence transformations because they change the location of the shape without changing the shape or size. So they don't change a triangle from a square or to a square. They don't change the size. It doesn't go from a small triangle to a big triangle. All this is doing is changing the location. So learn what each one of these is. How you do a translation, how to do a rotation, and how to do a reflection. If you know all those, it's going to help you. This is one of the easiest sections in the chapter, so this is basically 3 points on the test. Okay, coordinate notation for a translation. You can describe a translation by the notation XY, then the arrow, which means XY moves to X plus A and Y plus B. This shows that every point XY is translated horizontally by A units, so it's moved over by a number A units and vertically by B units. Now I'll show you how this coordinate notation works. So we have ABCD has vertices A, negative 4, 3, B, negative 2, 4, C, negative 1, 1, and D, negative 3, 1. Then sketch ABCD and its image after the translation XY moves to X plus 5, Y minus 2. So first we have to sketch the original ABCD. And so we go back 4, up 3, and make a point. So that's A. B is negative 2, 4. Over 2, up 4, that's B. C is negative 1, 1. And D is negative 3, 1. Okay. So we have a figure. Like this. Now it's X plus 5 and Y minus 2. So you can pick any point to start with. Let's start with C. It's X plus 5. So you go over 5. 1, 2, 3, 4, 5. And down 2. You make a dot. Now that is C with an apostrophe behind it, which means C prime. Then D, you move over 5. 1, 2, 3, 4, 5. And down 2. Now that's D prime. A prime, move over 5 and down 2. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then down 2, sorry. I was like, that does not look right. That's because it wasn't. That is A prime. Then B, 1, 2, 3, 4, 5. And down 2. 1, 2. 1, 2, 3, 4, 5, down 2. There we go, that's better. I would just draw lines in between them. and we're done. Should be exactly the same shape, should be exactly the same size. That's translations. Okay, I want you to try this one on your own. So pause the video, try it on your own, and then I will do it with you. So A's 5-2. So you're going to go over 5, and up 2. B is 3-3. So you go over 3, up 3. And C is 7-3. So you go over 7, 1, 2, 3, 4, 5, 6, 7, and up 3. Let's see. Okay. Now you're going to go x minus 5. So you go back 5, 1, 2, 3, 4, 5, and up 4. 1, 2, 3, 4. Make a dot. That's B. C is going back 5 and up 4. Go back 1, 2, 3, 4, 5, up 4. 1, 2, 3, 4. And A, go back 5 and up 4. Okay, now we make a dot, or make lines in between each dot. This one's off a little bit. There we go. Now you're good. So that's translation. It's pretty easy. All you do is move it however many units with the X and then with the Y. Okay. Coordinate notation for a reflection. Okay, if you're rotating or reflecting, if you're reflecting a figure across the x-axis, then you multiply the y-coordinate by -1. So if it's a reflection in the x-axis, which means it's flipping from here downward to here, then you multiply the y-coordinate by -1, and these would be your new coordinates. And so at this point here, is 2, 1. Then the same point down here is going to be 2, -1, because we just multiply that 1 by a -1, and that's it. So reflection in the X is pretty easy. If it's a reflection in the y-axis, you could have drawn all three of those on the same figure, like boom, boom, and then boom, boom, down here. If it's a reflection in the y-axis, then you just multiply the x-coordinate by -1. And so if this is 2, 2, 1, then we multiply the x-coordinate by -1, -2, 1. And that's it. So fairly easy for reflections. Just remember, if you're reflecting over the y, you multiply the x by a -1. If you're reflecting over the x, you multiply the y by -1. All right, you're drawing a sign. Use a reflection in the x-axis to draw the other half of the pattern. So basically, if you want to do this, you just look at the points. This is -1, 3. This is 4, 3. This is 4, 5. This is 0, 0, or whatever. I think 8, 9, 0. So whenever we are doing a reflection across the x-axis, remember we multiply the y by a -1. So if this was -1, 3, it's now -1, -1, -3. This one's going to be 4, -3. That's there. This one's going to be 4, -5. And then if it's 9, 0, you make 0 negative, it's still going to be 0. And you just draw the lines and connect it. You get this perfect arrow. So easy enough, right? All right. In this lesson, if a rotation is shown in the coordinate plane, the center of the rotation is the origin. And so if we're looking at rotating this figure, it's going to be based off of the origin that you're rotating. And so instead of just rotating it like this, it has to rotate based off of this point. So you draw a line to it. It always has to come from out of here. So if they want you to rotate it 90 degrees clockwise, then you would rotate it 90 degrees based on the end of that point, so that your triangle now comes down here instead of it just being a triangle spinning in a circle up here. It has to rotate downwards through the origin, through this point 0, 0. So this would be rotating 90 degrees clockwise. If it asks you to rotate 90 degrees counterclockwise, that's going to look like this. If it asks you to rotate 180 degrees, it's going to be coming down like this. Now, if it asks you to rotate 180 degrees clockwise, that's the same as doing counterclockwise. So it shouldn't ask you to do one way or another for 180 degrees. For 90s, it definitely will, though. All right, if you're a little confused, rotations are the hardest one. So it just takes some practice. You just have to get used to them. All right? Okay, thank you to all my unwilling participants for having their photos on there. Just having a little fun. Perry, you're lucky I couldn't find a picture of you real easy. All right, guys. Oh, before I'm done, I wanted to let you know I'm starting to post homeworks. So I know you've turned your homeworks in and gone through that whole process. Hopefully, the substitute has given you the papers back that I sent back. I realize this section is tough, so I'm going to start posting entire sections of homework, the videos online, so you can look or listen to them, look them over, check any questions that you might have had. Don't forget, you can always email me with questions too.